With Databricks Unity Catalog's volume feature, data management has become very easy. So now, regardless of your format and location of the data, organizations can now effortlessly organize and access their data sets without wasting their time to understand the underlying technology and the location. So that is why this Databricks volume feature is very game changing and critical. In this vlog, we are going to discuss about the Databricks data volume feature in Unity Catalog. So let's get started. Hello friends, welcome to my channel and explore the world of Microsoft Azure. My name is Rajneesh Kaushik and I'm a Microsoft certified trainer, consultant and an enterprise architect. For more latest videos and blogs, you can always log into my website rajneeshkaushik.com and subscribe to my blog. Please do not forget to subscribe my channel and click the bell icon so you don't miss the latest videos. Do like, share and comment. Unleashing the power of Databricks volumes in Databricks Unity Catalog. So here is the agenda for today's session. First, we are going to learn what are the volumes and why we need to use volumes. Then we will understand tables versus volumes in the Databricks Unity Catalog, the different type of volumes available in the Databricks Unity Catalog, and how to create volume in Databricks Unity Catalog. In this, we are also going to understand how to access the datasets and secure the Databricks volumes. And then finally, we will wrap up with the demo, where we are going to create a volume and then test it. So let's get started. Okay, so what are volumes? Volumes are actually catalog for file collections in the Databricks Unity Catalog, and this is a really a feature in the Unity Catalog, right? And why they are important? Because they really facilitate the scalable application handling for the large data sets. And this is very much important because if you have unstructured data and you want to use your governance capabilities, lineage capabilities to track these non-tabular data or unstructured data, we need to have a volume, right? And volume, the good part about volume is that it works seamlessly. So suppose now you are accessing a volume. Now you don't have to understand this volume is connected to a Azure storage or it is connected to the AWS bucket. So that is irrelevant because for you the one abstraction is volume and you will access that volume directly with the volume syntax. So this is why it is very game changer, because it hides the complexity of the underlying technology, and it also helps you to not just access the technology but also gain insight, and that too with the lineage and governance capabilities. So why volumes? Why we need to use volume? What are the benefits and use cases of volumes? So first and foremost is that if you want to use your machine learning experiments on unstructured data, then volumes are required, because volume in the volume you can store the collection of unstructured data sets such as images, videos or PDF files. Then volume can also be used for data sets for model training, because volume can be used for persisting these whole data sets and test and validate this data set for model training. And when you do that, you require a location for operating this model and model training, and you need to also log your experiments model and then checkpoint the directories. So there you can use these volumes. That for that data exploration capabilities, that means you are acquiring the non-tabular data sets or data exploration which is used in the data science world, you can use data volumes. There are the data volume actually works with different set of tool, so you don't have to understand the underlying technology. For you, the only abstraction is data volume. Then data volume also have you can access the files, not just file but libraries and different certificates and configuration files. You can use it in the same purpose. So think it as if it is a volume created in the Linux system. Similar kind of thing is there in Databricks. Then there are other use cases, like you can use volumes for data ingestion, like you can ingest the data with the autoloader or copy into file, copy into command. You can also use volume for sharing the files. Okay, and when you say sharing the file means you are sharing it within the workspace or across the workspaces, region, cloud, and different data platforms. So these are the separate use cases for uh, table versus volumes in Databricks Unity Catalog. So by this time you might be confused that what is the difference between tables versus volumes. So let's understand that. Tables can be used for structured and semi-structured data which can be organized in the rows and column. But volumes can be used for non-tabular data, which means that unstructured, semi-structured and structured data, all of them. So use cases which is very much useful for tables are SQL based operations and ETL processes. But for volumes, they are most suitable for machine learning, data science workloads. They can also be used for running the large machine learning models on the large collection of unstructured data sets, which is persisting across the different shares, and training and testing the models, doing the validations. And these can be, they are useful for working with tool that does not natively support cloud object storage APIs, right? So this is why it is very important that if you want to use some tools which does not natively support the cloud object storage API, it also helps you to provide the secure access to the file across the workspaces and data sharing and data ingestion. So this is why volume is very critical and game changing feature. Data management. Data management perspective, table supports the schema evolution. It can support, add, remove or manage the or change the data type of the column, while volumes are provide inherent capabilities for accessing, storing and managing the data in any of the format. They represent actually the logical volume of storage in the cloud object. So they are actually logically telling you that okay, this is a volume name, and behind the scene it might be connected to AWS, it might be connected to Azure, or it might be connected to GCP. Then the difference between the integration. Tables are typically used in conjunction with data frames in Apache Spark, but volumes are actually abstraction, as I just told you, and it is a API cloud specific. So it is actually abstraction on the API which is provided by the cloud provider. Like in Azure, we have a Azure specific API for accessing the storage account, and AWS we have a AWS bucket specific API. So behind the scene, AWS bucket is using or Azure is using does not matter. For you, it is a volume which you need to access. So then another thing is that it making it easier for users, and also it also works for those applications which does not support your object storage APIs. That means suppose one application which does not support Azure storage, but it supports the volume, it will work very well with this kind of approach. Tables are cataloged in Unity Catalog, and they can be discovered and governed using the catalog feature. Volumes actually a new type of object in the catalog, and that catalog and that contains of this could be catalog as a collection of directories and files in the Unity Catalog. So they also enable you to govern, manage and track the lineage, but that is specifically for the non-tabular data sets. Okay, and you can also use tabular data set as well, and you can also use your models for a unified discovery and governance. So these are the critical difference between tables and volumes. There are two types of volumes in Databricks Unity Catalog. Managed volume and external volume. Managed volumes are actually used when you want to store the files in the default storage location for the Unity Catalog schema. But in case of external volume, when you want to store your files in the external storage location, you will use external volume. Now you might be thinking about how do I access the data which is stored in the volume. So these are the syntax and examples. Suppose you want to create a volume, you can create a volume like this in the SQL syntax. You want to grant a permission to the volume, you can grant it with the grant syntax, which is a plain vanilla SQL syntax. You can extract the archive in the volume, like suppose this is a zip file, you want to archive, extract it, and you can use this unzip command. You can also access a volume's content in a notebook with the help of this example. Like this one, you are importing and classifying the particular JPG file. You can load a model from the volume. So suppose this is your model registry, and there your model is stored in the volume, and you can just use this model with the model URI as a you know uniform resource identifier, and then based on that you can access this whole model from the volume. Then you can also list files in the volume, like this is an example of listing the files in the volume. Similarly, the way you read the text file in the Spark, so instead of that you can use volume directly, and similarly you want to read the CSV file which is located in a volume, you can just use this syntax. So it's pretty familiar syntax actually, right? Not much of the change, and that helps you to use it seamlessly. Like a couple of other examples, like reading a CSV file for the pandas, so pd.read CSV and then volume. Download the file from the shell command, like curl command, and then you can put a volume. Installing the library pip install and the library location in the volume, or listing the directory, again that is from the directory location. So these are the options for accessing the data in the volume. Okay, so demo time now. As a part of this demo, I am going to explain you all this functionality and then showcase that how the volume works. So first we are going to create a access connector, and then we will create a storage account and add a container in the storage account. Then we will grant this access connector access to the storage account. That access will be storage blob contributor access. Then we will create a container in the storage account, and then based on after that we will create a metastore, and in that metastore we will add a root storage credential for that metastore. Now once this step is done, then in the 7th step we are going to create a volume, upload a file in the volume and test the volume. So let's jump to this demo. Okay, so first and foremost we are going to create a storage account. So let's do the storage account creation. So this storage account I'm going to create the name Unity Catalog storage account using this Databricks resource group, and I'm putting the name Unity Catalog Demo 7 just to make it unique one. In the advanced tab, this is the most important step, so let's not forget it. Enable hierarchical namespace, networking, and then remaining things you can just put the way it is, and review and create. So now your storage account is almost created. In the meantime the storage account is created, let's create a access connector. So let me show you how to go to access connector. So if you search access connector for Azure Databricks and then create, and then here I will say that the resource group will remain the same, and then my access connector, that is the name of my access connector. Review and create So now once this is created, then it is going to create a resource ID, and I am going to store this resource ID here in a notepad. So this is a resource ID, it is created, and I am going to just save it in a file here just for the sake of convenience. So now I am going to go back to my storage account and grant access to that storage account with access control, add role assignment, and in that I am going to say storage blob contributor, data contributor, and this time I am going to use manager identity, because we are going to use manager identity of your access connector. This is my access connector manager identity, and I'm going to select it and review and assign. That means now my access connector has access to the storage account. So access connector is nothing but a abstraction layer on the top of Databricks, which is actually calling the storage account to get access, and after the access is granted, it seamlessly work with the storage account. So with this we have created the storage account and access connector and grant the necessary permission to the access connector. So now let's work on the next part of it. So with this I'm going to first go to the my Databricks workspace, and Databricks workspace I'm going to go to the admin console. So I'm going to go to manage account. In manage account I'm going to create a meta store, and meta store will be demo meta store, and create a meta store. So there is no, there is nothing, but I'm going to create a new one, create meta store. And then region, I'm going to use the same region, East US. And this is very important, ADLS Gen 2, path of the ADLS Gen 2, which I will just give you in next 1 minute. But before that path could be given, let's use the access connector. The access connector is already stored here. So access connector ID we will use. And then here we are going to use the path in the container name at the storage account name dfs.core windows.net path. So if suppose we want to create a container name at utility Unity Catalog demo, volume demo. So if suppose this is your container name, and then let's write it down here in the same fashion so that it becomes easy for you. And obviously we have not created a container, but I'm going to create the volume demo container, and then at the rate of storage account. So it is the, what is the storage account name? Let's see. So this is our storage account name. And let's put the storage account name here. Dot DFS .core.windows.net, dfs.core.windows.net. and then slash. So now let's go to storage account and create a volume demo and see if the volume demo exists or not. So we will come here in the container. Okay, for some reason it is not working, so let's, I think there is some problem, unresponsive. Okay, so now let's come here, container name, volume demo, and then create. So volume demo is created now, and we have this path also applicable now because the volume is created, volume demo is created. So let's come here and give a ADLS Gen 2 path and create. So before you go further, advanced options, there is nothing there. We are not getting into this option, but let's see whether it is created or not. It is created. Now the next step is assign this demo meta store to the workspace. So we have only one workspace, so I'm going to add that, assign it to this workspace and enable. So with this, the workspace assignment is done. Now let's go back to the, so it is saying that congratulations. So now come here in the data, and demo meta store is already there, and workspace is also assigned to it. So now what we will do, we will go to Databricks workspace and come here in a data option. In the data option we will see that there are these in the data explorer, it will show you multiple options. So in the meantime, what we will do, we will start the cluster as well at the same time. And let me duplicate this tab. and then while that page is loading, I'm going to go to compute and then start the cluster. So after that I'll go back here and refresh it. Okay, so now before we do anything, we will add a storage credential. So for storage credential, I'm going to say my credential access connector ID. It is also asking access connector ID, and I've already provided the access connector ID earlier, so I'm going to use the same one. And then I will put that comment as a storage credential and create. So access credential is also created. Now let's come back here in the data tab and come here and then create a volume here. So let's create a volume. The volume name will be Rajneesh volume. Create. So volume is successfully created. Now we will grant a permission to this volume. So I'm going to grant all the permission, all the privileges, but you can create only read or write or whatever you want. Just for the sake of simplicity, I'm going to use this option, grant. And once this permission is granted, I'm going to upload some file to the volume. So for that, I'm going to drag and drop some files here. So for that, I have already downloaded a file, and that download link is also given in my blog. I am just uploading this zip file. Actually, this is a little bit bigger zip file, so I am uploading it here and put a upload button. And once I do upload, it will start uploading this big file, which is like a couple of MBs, and then it will start uploading this file into the cluster. So let's wait for the file to be uploaded fully. Now you can see that the file is already uploaded in the volume. So now what we will do, we will actually go back to our recent notebook, and in that notebook we will see that whatever the experiment we are going to conduct on this workspace. So let's see. So this is my recent notebook, volume testing with notebook, and in this we will have this command. This command actually uses a volume created by me, and then it is going to unzip these values here. So I've already run this command, and instead of running this command, because it is a huge volume, 1 GB of data, so what I did, I'm going to just run it for a couple of minutes, and once the command is running successfully, I'm going to stop it because I only need 1 or 2 JPG files. So let's see. So it's saying that permission denied. Okay, not sure why this command was failing. I did not do anything. I reran it again and it started working fine. So you can see that it is unzipped some files by creating a folder inside this, and instead of running this command for a couple of minutes, because it is still unzipping it, I'm going to just stop this command by cancelling it. So because I still have the data already available, and my next command will actually use this data. So in this case, I'm going to use this particular file 0.jpg and trying to access this particular file. So because this is already extracted, so let me cancel everything. When I cancel it, it means that it is stopped inflating those files. Now let's run this command. So either I can run 1.zip or 2.zip. So let me do 1.jpg, and I'm going to run this command, and you can see that it started creating an image. So that means this image is rendered with this particular jpg file, which is stored in the volume. So with this we have done end-to-end demo for our Databricks, where we have showcased the end-to-end picture about how do we create a access connector, how do we create a storage account, and then container inside the storage account, how do we grant the access to the access connector to the storage account, how do we create a meta store, and how do we add a storage credential to the meta store, and then how do we create a volume and then upload some data into the volume and use a notebook to access that data set. Thanks for watching, and do not forget to subscribe and